Miscellaneous exercise 9, first question. For an arithmetic progression for an AP, let's consider A1 equals to A, means first term equals to A and common difference equals to small d. Now what is asked to prove? We are asked to prove that summation of m plus nth term, that is a m plus n plus a m minus n equals to twice am. This is what we want to prove for an arithmetic progression. So we just write the formulas for these two and we'll add them. So here what is am plus n? That is equals to a plus m plus n minus 1 into d, and what is am minus n? That is a plus m minus n minus 1 into d. You know, nth term formula for an arithmetic progression. Now we'll just add these two. So therefore left hand side expression, adding these two. So a plus m plus n minus 1 into d plus this expression a plus m minus n minus 1 into d. This gives us 2a plus a. Take d common from this 2. I'll take d common. So this plus this. So n will get cancelled. What will get here? M plus m 2m minus 1 minus 2. That is minus 2. You can find 2 common. So what will get? A plus m minus 1 into d. And what is this? You know that this is just nothing but which term? Nth term, and that is the right hand side, and therefore proved. Right? You know, just by placing the formulas. Started with LHS, then just we have placed the formula. Okay, next question. What you are asked, sum of the three numbers of an AP is 24 and their product equals to 440. Find the numbers. Okay, so here let three numbers be this in AP. Let three numbers be, we select like this normally, a minus d, a and a plus d. In GP, if you remember, we had selected like this for a geometric progression. Three numbers, if you remember, a by r, a and ar. This way we select the three numbers in geometric progression. For an AP, three numbers we select like this. Why these three numbers forms an arithmetic progression? You can see that there is a common difference equals to small d. Three numbers be this, and this are in which progression? Are in arithmetic progression. Okay, now we are asked to find these three numbers. So what we need to find? We find a and d and place here. So we have two conditions. Which two conditions we are given? Given that summation is 24. Summation equals to 24. So therefore a minus d plus a plus d equals to 24. So dd will get cancelled. You have 3a equals to 24. So you will get the a equals to 8. Right? You are given this. If I add them, you will get the 24 and therefore a is 8. Fine. And one more condition also you are given. And what is that condition? The product is 440. So a minus d into a plus d equals to how much? 440. We know a, so from this we'll get the d. Right? A is known to us, which is 8. So if you combine these two, this is 8 square minus d square into 8 equals to 440. So what we'll get from this? 64 minus d squared equals to, we'll get here 440 divided by 8, which will be just 55. 440 divided by 8, take it down, So we'll get the d square equals to here 64 minus 55, right? And which will be 9 here, and therefore there are two possibilities for d. Either d is plus 3 or d is minus 3. Minus 3 or plus 3. So a is fixed. A you were knowing 8. So therefore numbers are, what about the numbers here? Numbers are a minus d, a and a plus d. So 8 minus 3, 5. This is 8 and 8 plus 3, this is 11. Or what about this? Here a is 8, that's fixed. Your numbers are, what are the numbers? A minus d, a and a plus d. Now a minus d means 8 plus 3. Here it is 11, then 8, and then this is 5, just in the reverse order, right? So either we have this or this. These three numbers in arithmetic progression satisfy given condition, right? Both are same, just order is reversed here. That is the only difference. Let's go to third question. Question number 3. Third question. You are given S1, S2 and S3 and you want to prove this. Okay, so let's write what is given here. S1. What is S1? Sum of n terms, which is Sn. So S1 equals to, you can just write the formula. What's the formula? N by 2, for arithmetic progression, 2a plus n minus 1 into d. Fine. What is S2? That is the sum of how many numbers? 2n numbers. In the question itself it is given. So what is S2 here? That is 2n by 2 into 2a plus 2n minus 1 into d. Sum of the 2n terms of an AP. And what about S3? And S3, that is sum of how many terms? Sum of 3n terms. So S3n, so it will be S3 equals to 3n by 2, 2a plus 3n minus 1 into d. Just we have stated one formula how many times? 3 times. Sum of n terms, 2n terms and 3n terms of an arithmetic progression. Fine. Now, very simple. What you can do is, you can start with RHS of what you want to prove. You want to prove this. Let me write that. We prove this. This is what you are asked. We prove that S3 equals to 3 times S2 minus S1. So start with this. I'll not do it, you can do it. Just place the value here. You keep 3 as it is. Put the value of S2, put the value of S1, simplify. So you are left with formula of S3. So you can do it. Just place on the right hand side these two values. Simplify, immediately you'll get this formula. So that much you can do. The next question, we want sum of all numbers between 200 and 400 which are divisible by 7. So let me write here numbers between 200 and 400 divisible by 7, which are divisible by here 7. So the numbers are this. First number will be, you can just verify, if you divide 201 by 7, remainder will be 5. So our first number will be 203. This is the first number which is divisible by 7 after 200. Now you just keep on adding 7. So 210, then 217 and so on. The last number is 399 before 400. These are the list of the numbers divisible by 7 between 200 and 400. So here this is A, this is L, last term. This is an AP, we know. but we need to find n. What is n? How many numbers are there? That we need to find. So for that you can use this formula. An means this last term, a plus n minus 1 into d. If you use this, you can get the number of terms. An means 399, a means 203, n minus 1 into d. What is d? Which is 7. So let's simplify this. Here you will get 399 minus 203 equals to n minus 1 into 7. So what we'll get from this? We'll get just 196 equals to n minus 1 into 7. And therefore n minus 1 equals to 28 dividing by 7. So n equals to 29. So there are 29 terms between 200 and 400 which are divisible by 7. Okay. So therefore, let me write here required summation, required sum, that is equals to n by 2, 29 by 2 into a plus l. So 29 by 2, what is a? A is 203, we already noted. A we know it is 203. What is last term? 399. So this will be 29 by 2 into, this is how much? We know 602. So 29 into 301, and therefore if you just multiply, we'll get 8729. Required summation. That's the sum of all the numbers between these two which are divisible by 7. Just you have formed the AP, and then you have just counted how many terms are there within this formula. So there are 29 terms, and then we have used SN formula. Okay. Fifth question. Sum of integers from 1 to 100 that are divisible by either 2 or 5. Right. What's the question here? Sum of all numbers from 1 to 100 which are divisible by 2 or 5. It's just same question. So here how we'll do this, that's a question. Now in such questions we find all numbers which are divisible by 2 or number which are divisible by 5 minus numbers divisible by both, that is 10, 20, all these numbers should not come, remember. Sum of all numbers divisible by 2 or 5 means what? Not divisible by both. Both means what? 10, 20 and so on, all should not be there. Okay, so I'll write here, let me write here, required summation. Required summation means what? Sum of all the numbers from 1 to 100 which are divisible by 2 or 5. That equals to sum of all numbers divisible by 2 plus from 1 to 100 we are talking, plus here sum of all numbers from 1 to 100, all numbers divisible by 5 minus not both, that is sum of all numbers divisible by this and this, that is 10, into LCM of 2 and 5 which is 10. Right, we'll do this, so I'll get the required summation. I repeat, required summation means what? Sum of all the numbers from 1 to 100. Here numbers are from 1 to 100. Numbers from where to where? 1, 2 up to 100. So required summation means sum of all the numbers which are divisible by 2 plus sum of all numbers which are divisible by 5 minus sum of all the numbers which are divisible by 2 and 5 which is 10. So we get this, we add them, we subtract this, right? Okay, so if you just recall, it is that intersection here This is A plus B minus intersection. This is just union formula. I'll just remind you, it is just this one, n of A union B, that is n of A plus n of B minus n of A intersection B. I hope this must be clear to you. N of A means numbers divisible by 2, n of B means number divisible by 5, minus intersection means both, all numbers divisible by 10, right? I'm emphasizing this is nothing but that union formula from sets. Okay, now first numbers divisible by 2. So numbers divisible by 2, that is 2, 4, 6 and so on. The last one is, second last is 98, last one is 100. So we know that here clearly, being even number, there will be total 50. That's quite obvious. Fine. And therefore here summation equals to, so summation in this case, which will be n by 2, 50 by 2 into A means 2, L means here 100, L means what? Here 100. You have used which formula? N by 2 A plus L formula. So what we'll get here? We'll get 25 into, this is nothing but the 102. So we'll get the 2550. This is the sum of all the numbers divisible by 2. Same way, now we'll get the numbers divisible by 5. That is 5, 10, 15 and so on, 100 here. Okay, so how many such numbers which you can write very easily here? That's obvious, n equals to 20. 20 into 5, that is 100. Or you can use this formula, an equals to a plus n minus 1 into d. An means you put 100, a means put 5 here, d means 5 here. Simplify, you will get n equals to 20. There are 20 such numbers. Okay, so therefore here summation equals to 20 by 2 A plus L. A means 5, this is 100. So we'll get here 10 into, what is this? This is 105. So how much? This is nothing but the 1050. Fine. Now numbers which are divisible by both. Numbers divisible by both 2 and 5. 2 and 5. That is 10. 2 and 5, it means 10. Numbers which are divisible by both, which is 10 here. Okay, so these numbers are this. So you have first number 10, then 20, then 30, then 40 and so on. Last one is 100. So such numbers are obviously, you can write here n equals to 10. How many such numbers? 10 numbers, which is very obvious to count, not a big task. So here summation equals to n by 2, 10 by 2, a plus l, 10 plus last one, that is 100. This is a, this is l, this is a, this is l, we know. So what is this? Which is equals to here 5 into 110, which is nothing but the 550. Okay, and therefore the required summation, the required sum equals to, from the equation number 1, we have 2550 plus 1050 minus 550, right? So let's simplify this. If we simplify, I'll get the 3050. From where we could write this we wrote by equation number 1. Have a look at 1. The one was this. This was equation number 1. All numbers divisible by 2, 5 minus all numbers divisible by 10. So this is required summation. Okay. Now next question here. So here we want all numbers which are 2 digit. When divided by 4, it gives remainder 4. So that means numbers are of this type. Numbers are 4k plus 1. When you divide this 4k plus 1 numbers by 4, remainder is 1. But we want 2 digit numbers. So 2 digit numbers here of this type. Put k equals to 1, so we'll get the 5, which is not 2 digit. Put 2. So 8 plus 1, 9, again not 2 digit. Put 3 here. So 12 plus 1, so first is 13. Now just keep on adding 4. So next 17, 16 plus 1. Next you add again 4, so 21. And so on. The last number you can verify it is 97. I'll leave it to you. So 2 digit numbers which are of the form 4k plus 1 are this. It's obviously an AP where this is the first term, this is the last term. L. So you need to find what is N. What we do for that? We start with nth term formula. An equals to A plus N minus 1 into D. What is An? 97. A 13. Plus n minus 1 into d. What's d? Obviously it is 4. So here if we simplify, we'll just have 97 equals to minus 13 equals to n minus 1 into 4. Okay, so this is 84 equals to n minus 1 into 4. So n minus 1 equals to what we'll get? 21. And therefore n is 22 here. Okay, now from this we can get the required summation. I'll write required summation, that is the sum of all such numbers, 2 digit numbers when divided by 4, remainder is 1. That is equals to this formula, n by 2 a plus l. Okay, what is n here? You know, 22 by 2 a means the first term, which is 13 here, and this is nothing but how much? Last term, which is 97. So we'll get the 11 into 110, so we'll get the 121 into 10, so which is 0. That's a required summation. Okay, next question. So here we have a function which satisfies this condition, f of x plus y equals to f of x into f of y. One is this. We are also given that f of 1 is 3. And here sigma x run from 1 to n fx equals to 120. That's also given to us. What's the meaning of this? If I take different values of x here, put 1 here, f of 1, sigma means plus, f of 2, next is 3, and so on. Finally it is f of n equals to 120. That is given to us. And what is asked? We are asked to find n. What is the value of n? That's the question. Now here f of 1 you are given, that's 3. So we find f of 2, f of 3 and f of n we put in this expression. Let me call this as just 1. Okay, we find f of 2. How do we find f of 2? With the help of this relation. So let's find what is f of 2. Now f of 2 I can write as here the addition 1 plus 1. x plus y. Now that I can write as f of 1 into f of 1 as per this. This is given, remember. Addition you can express as what? Multiplication as per this information. But what is f of 1? That is 3. This is also 3. So 3 into 3. So we'll get the 3 square. So f of 2 is 3 square. Now again, if I go for, f of 3, next number I want this. So that I can write like 1 plus 2 because I know f of 2 now. So as per this definition, I can write f of 1 into f of 2. This is 3, this is 3 squared. So what we'll get from this? 3 cube. So f of 3 is 3 cube. Fine, and so on. What is f of 4 from this? It is 3 raised to 4. What is f of n? It will be 3 raised to n. So we put all these values where? In the equation number 1. So I'll write by 1, f of 1 you are given 3, f of 2 3 square, f of 3 3 cube, and so on. What is f of n? 3 raised to n. That is equals to how much? 120. Now what is this left hand side? We know that it's a geometric progression. This is GP, remember. This is GP, where first term is 3, common ratio is also 3, these upon this which is 3, these upon this which is 3, and therefore you can write the sum of how many terms? 1, 2, 3 up to n terms, which is given by a into a means 3, r raised to n. So 3 raised to n minus 1 upon r minus 1. 3 minus 1 equals to how much? 120. Fine. I hope up to this it is clear to you. Am I right? The important one is this calculation of the function. Y f of 2 is this, y f of 3 is this, and then we wrote inductively. And then this becomes just a geometric progression. And this just we have placed the value in the equation number 1. So if I just simplify here, we have 3 by 2 into 3 raised to n minus 1 equals to how much? 120. So 3 raised to n minus 1 equals to 120 into 2 by 3. Right? So this will be just 40 into 2. So 3 raised to n minus 1 equals to 80. And therefore 3 raised to n equals to 81. And 81 you can write as 3 raised to 4. So therefore number of terms must be 4. We must have 4 terms. The 8th question, summation of some terms for a GP is 315. So for a geometric progression, we are given that Sn equals to 315. Okay. First term and the common ratio, here a is 5 and the common ratio is 2. That is also given to us. What is asked? Find the last term and the number of terms. So we find an and n. These two things we are asked to find. Okay. So we start with Sn here. So here Sn equals to, you have 315. What is Sn for a geometric progression? A into r raised to n minus 1 upon r minus 1 equals to 315. Fine. Now you know A, you know R, place the value here. So from this you will get the n. And once you get the n, you just find an. Right? So an, you know A into r raised to n minus 1. So this much I leave it for you. Very simple for you. 9th question. First term of a geometric progression is 1. So for a geometric progression, A is 1. The summation of third term, that is A3, and the fifth term, that is A5, equals to 90. Okay, so let's write the formula for this. What is this? A into r square plus a into r raised to 4 equals to 90. But we know a is 1, so r raised to 4 plus r square minus 90 equals to 0. Now this is a biquadratic equation, so we can factorize here like this: r square into equals to 0. Find two numbers whose product is here minus 90 and summation is plus 1. So our obvious plus 10 and minus 9. Okay, but r square plus 10 never be 0 because it becomes a complex number. So therefore r square minus 9 must be 0. Reason? Because r square plus 10, we know this is never be 0. So r square plus 10, r square minus 9 has to be 0, and therefore r has to be plus or minus 3. And that's what you want. Common ratio is plus or minus 3 here. Then 10th question. Sum of the three numbers in geometric progression is 56. So we need to take three numbers in GP. Let three numbers in GP be A, then AR, and I'll take AR square. You know, these are the three numbers in geometric progression. In fact, the first three numbers in geometric progression. So therefore, we have the summation A plus AR squared equals to, we are given 56. You can take A common, so 1 plus R squared equals to 56. Call this as 1. Okay, one more condition we have. If we subtract 1, 7 and 21 from this respectively, then we get an arithmetic progression. And now we subtract 1 from this, so A minus 1, 7 from this, that is AR minus 7, AR squared minus 21 is an AP. This is an arithmetic progression. So the difference will be same. This minus this equals to this minus this. So if we use that, we'll get 2 times AR minus 7 equals to A minus 1 plus AR square minus 21. Right? Which condition I've used? They are in AP. So this minus this equals to this minus this. I've used this. Let me show you here. If these three numbers are in arithmetic progression, then B minus A equals to C minus B. Ratio difference should be same, not ratio. B minus A, that difference equals to C minus B. So from this what we'll get? 2B equals to A plus C. Take A on the other side, C on this side. So 2B, middle term. Twice of this equals to A plus C. Okay, so you simplify this and now you just solve these two equations for A and R. Solving 1 and 2. I'll not do this, just open this bracket, simplify. With the help of 1 and 2, you will get the values of what? A and R. You get the values of A and R, and then you can place those values there. You will get A and R here, and place these values over here, so you'll get the required numbers of geometric progression or required terms of the geometric progression. So in the 11th question, we are given that for a geometric progression, sum of the all terms is 5 times the summation of terms occupying odd places. Okay, so here let GP be this, geometric progression be this A, AR, AR squared, AR cube and so on. This be geometric progression with even terms, even number of terms. Okay, so we have even number of terms. So therefore here a1 plus a2 plus a3 and so on up to a2n. 2n means even number of terms equals to 5 times, this is given 5 times the terms occupying odd places. Odd places means 1, 3 and so on. So we have a1 plus a3, a5 and so on. Odd place means which place here? a2n, here minus 1, odd place. Fine? Is this correct? Term occupying odd places. So 1, 3, 5 and so on. This is given information. Now this much is given that, let me write this, given that this equals to this. Now this is sum of the all n terms here. This is a geometric progression with the first term equals to a and the common ratio equals to r, ratio equals to small r here. So you can add all these terms. This is also geometric progression. Have a look at this. Alternative terms, this, then this, the next one will be here and so on. So this is a GP with a1 equals to here again a, and the ratio will be r square here. Ratio is, you can see this upon this, which is r squared, not r. That is the difference. Here r square, here ratio is r, because you are taking first term, then third term, then fifth term. Right, so you can verify, if you do this upon this, you will get the r squared. That's the only important thing we need to note in this entire solution. Now we just write the formula. Okay, sum of how many terms here? 2n terms. A into r raised to 2n minus 1 upon r minus 1 equals to here 5 times. Here how many terms? You have just taken terms occupied all odd places. So total there will be n terms. How many terms? N terms. What's the first term? A. Common ratio r squared. Total number of terms, that is n, minus 1 upon, we have here r squared minus 1. Got it? Common ratio is r squared. The same formula here, ratio was r, but the total number of terms were 2n. Your ratio is r square, but total number of terms here n. Number of terms equals to n, because you are taking half term. Term occupying odd places. Okay, so this will get cancelled. This is r raised to 2n. So this bracket will get cancelled with this. Here we are left with this much upon 5 upon r minus 1 into r plus 1. So this factor will get cancelled. Here we have r plus 1 equals to 5 and therefore r equals to 4. That's required ratio. You are asked for ratio. The required ratio equals to 4. Twelfth question, sum of the first 4 terms of an AP. So for an arithmetic progression, S4 equals to 56. What's the formula for S4? We know n by 2, so here 4 by 2 into 2a plus 4 minus 1 and minus 1 into d equals to 56. So it implies what we'll get from this. This is equals to, we'll get the 2 into 2a plus, this is 3d equals to 56. So we'll get the 2a plus 3d equals to 28. This is one equation about a and d. Okay. Now we are given the sum of the last 4 terms. So, and let's write that sum of the last 4 terms. Sum of last 4 terms equals to how much we are given? 112. Last term we know, that is a plus n minus 1 into d. This is the last term. What's the previous term? A plus, you do minus 1, n minus 2 into d. What's the previous term? A plus n minus 3, 1 less d. What's the previous one? That is a plus n minus 4 into d. 1, 2, 3 and 4. You know that this is the last term, equals to 112. This much is given. So if you add all this, a plus a, which is how much? 4a. Fine. From the remaining terms, you take d common. So n, how many times? 4 times. 4n. And what about this? 7 plus 3, 10. So here minus 10d equals to 112. Okay, so we have here a equals to 11 in the question you are given. So by 1, if you put a equals to 11 in the first equation, you have 2 into 11 plus 3d equals to 28. So 3d equals to, we'll have 28 minus 22, so 6. So therefore d is 2. We got the d now. So using 2, if you use now second equation, which is 4a plus 4n minus 10 into d equals to 112. Let's put a and d both here. So you will get the value of n. That's what you are asked, number of terms. So 4 into a, that's 11 here, plus 4n minus 10 into d is 2, now we got, equals to 112. So we have 4n minus 10 into 2 equals to 112 minus 48, which is nothing but the 68. So 4n minus 10 equals to, just take on the other side, so we'll get the half, which is 34. So 4n equals to 44, and therefore n equals to 11. So number of terms equals to 11. In the 13th question, you are given that these three ratios are equal. You want to show that a, b, c, d are in geometric progression. So ratio should be same. Which ratio? A, B, C, D are in GP, means B by A should be same as C by B equals to D by C. These three ratios should be same. That's what you want to prove. That means A, B, C, D are in geometric progression. So what we do, we first start with these two ratios. We do the cross multiplication. A plus bx into b minus cx equals to b plus cx into a minus bx. Just open the bracket and simplify. You will notice that at the end you will get the b by a equals to c by b. Keep inside. Okay, call this as 1. Go to the other side. There again you start with these two ratios. Do the cross multiplication. B plus cx into c minus dx equals to c plus dx into b minus cx. If you again open the bracket and if we simplify, at the end we'll get here c by b equals to d by c. Just open the bracket, immediately you will realize this. Okay, and therefore from 1 and 2, these two ratios must be equal. From 1 and 2, b by a equals to c by b equals to d by c. And therefore a, b, c and d are in geometric progression. Are in GP means this upon this equals to this upon this equals to this upon this. Right? So therefore this is proved. So in the 14th question, for a geometric progression, for a GP, let's take this A, AR, AR squared and so on. This be a geometric progression. You are given that S equals to sum of all terms Sn, which is A into, R raised to n minus 1 upon R minus 1. that is S. Okay, what is P? That's a product. P is equals to product, that is A into AR into AR square and so on. The last term is A into R raised to n minus 1. So here A will occur how many times? N times. It will be A raised to n into R raised to 1 plus 2 plus 3 up to which number? N minus 1. So this is sum of how many terms? We know, we already discussed now in the previous unit. That is 1 plus 2 plus 3. If you have summation up to n, if you remember, it is given by n by 2 into n plus 1. Last number plus 1 by 2. So here, from this, we'll get this is equals to A raised to n into R raised to, last number is n minus 1 plus 1, which is n by 2. This is P. Let me call this as 2. Right? You have used this formula n into n plus 1 by 2 as I have explained on the previous page. Okay, so product of n terms, we have this. Now, next one, that is R. What is that? It is a sum of reciprocals of n terms. Reciprocals of n terms. Okay, so we take the reciprocals of individual terms and we'll add them. 1 upon A plus 1 upon AR plus 1 upon AR squared and so on up to 1 upon AR raised to n minus 1. So now we just need to simplify this here. What is common? That is 1 upon A. That is common. And what else you can find? You can take R raised to n as an LCM. R raised to n minus 1 as the LCM. So here this is R raised to n minus 1 plus 1 already used. So R raised to n minus 2 and so on. The last term will be just 1. Fine. Just think for a while. Taking A common, so outside, and R raised to n minus 1 as the LCM. Here you have just 1. So R raised to n minus 1. R is already there. So 1 less power and this entire you have taken outside. So this is 1. Now what is this? This is a geometric progression. What's the first term there? First term is 1. Here A1 is 1. And what's a common ratio? You can see it is just R. So you can add how many terms of this geometric progression? Can you think how many terms are there in this GP? Starting from 1 to n minus 1. So there are n terms. So we are adding n terms of a geometric progression where first term is 1. A equals to A1 equals to 1. 1 into common ratio is R. How many terms? N term raised to n minus 1 upon R minus 1. This is nothing but R. Okay. So let me rewrite just R raised to n minus 1 upon A into R raised to n minus 1 into R minus 1. I repeat this. This is a geometric progression with the first term A1 equals to A equals to 1. What's the common ratio? Term upon previous term. It will be small r. How many terms you are going to adding here? N terms. So A means 1. R raised to n minus 1 because common ratio R upon R minus 1. So therefore R is this. Now what you want to prove? Just look at it required expression. You want to show that P square. So now what is LHS? Left hand side expression, which is P squared into R raised to n. P square. So we are squaring this. So it will be A raised to 2n. Power of the power gets multiplied into R raised to, this 2 will get cancelled. So it is n into n minus 1. And r raised to n, take the nth power of this. So here r raised to n minus 1 the whole raised to n upon, here we are taking nth power, so a raised to n, this is r raised to n minus 1 into n, power of the power gets multiplied, into r minus 1 the whole raised to n. Is this fine? What I did, first I wrote p square, so square this, so here 2n, that 2 will get cancelled, so n into n minus 1. Okay, and then r raised to n, so you have raised to n, here you have raised to n, here raised to n, so that power of the power gets multiplied, r minus 1 raised to n. You will see that here number of things will get cancelled. This term will get cancelled with this. Here you are left with just a raised to n. This is r raised to n minus 1 the whole raised to n upon r minus 1 the whole raised to n. Now what is this? This is just nothing but, what is this? This is nothing but a into r raised to n minus 1 upon r minus 1 the whole raised to n. Right? This n, this n and this n, that power I have taken outside. And this is nothing but just, look at 1, that is Sn. So that is Sn means S here, that is S raised to n. This is because of equation number 1, and therefore proved. That's what you wanted to prove. P square into r raised to n equals to S raised to n, and therefore proved. The 15th question, for an arithmetic progression for an AP, small a is nothing but the pth term. So you can write small a equals to, your small a is already used, so I'll write a plus your p minus 1 into common difference equals to small d. Right? Let a1 equals to, I've used capital A, and the common difference equals to small d. For an arithmetic progression, I've written first term as big A. Why not use small a? Because small a is already used in the data. What is small b? Which is nothing but the qth term. That is which term? Qth term, aq. So b equals to a plus q minus 1 into d. And what is small c? That is nothing but the rth term. So here, what is that? C equals to a plus r minus 1 into d. Right? Now, very simple. We start with left hand side of the given expression. What is the left hand side? Q minus r into small a, r minus p into small b, plus p minus q into small c. We just place the values of now what? You know, a, b and c. We place the value of a, b and c. So q minus r into a, that is this much. A plus p minus 1 into d, plus r minus p into b. What is b here? This much. This is b. A plus q minus 1 into d, plus now last term here, that is p minus q into c. What is c? That is a plus r minus 1 into d. Okay? Now we just simplify and we'll see that this is 0. How will simplify? You open the bracket. From these three terms you take a common. From this, this and this. So what I'll get inside the bracket? Q minus r, here r minus p, and here p minus q. So you will see that internally all terms will get cancelled. So this is 0. Plus now this into this, this into this, this into this. I'll take d common. What will get here? Q minus r into p minus 1 plus here r minus p into q minus 1 plus p minus q into r minus 1, that d are taken outside. If I open the bracket, you see here pq, here you minus pq. So here also all terms will get cancelled internally. So you'll get a into here 0 plus d into here also 0. So this is equals to 0, and which is RHS. And therefore proved.